Hello, and welcome to today's Continuum Analytics webinar, 3 ways to move your data science projects into production, secure and scalable data science deployment from Anaconda, presented by Continuum Analytics Senior Data Scientist Christine Doig and Product Manager Kris Overholt. My name is Jessica and I'll be your moderator. We'll get started in a few moments, but first a few housekeeping items. We are recording today's webinar and we'll email you a link to the recording as well as the slides. You may submit questions at any time by typing in the chat box located towards the bottom of the GoToWebinar panel. If you do not see the box, click on the orange arrow to expand the dock. If you have technical issues, please contact Citrix toll-free at 855-202-7959. I'll share this number again with you via the chat. Now, I'm pleased to introduce today's presenters. Christine Doig is a senior data scientist at Continuum Analytics, where she worked on MEMEX, a DARPA-funded project helping stop human trafficking. She's the co-author of the recently published book, Breaking Data Science Open, published by O'Reilly. She has more than 5 years of experience in analytics, operations research, and machine learning in a variety of industries, including energy, manufacturing, and banking. Christine holds a MS in Industrial Engineering from the Polytechnic University of Catalonia in Barcelona. She's an open source advocate and has spoken at PyData, EuroPython, SciPy, PyCon, and many other conferences. Kris Overholt is a product manager at Continuum Analytics, developing the cluster management features of Anaconda. He has more than a decade of experience in scientific computing, systems administration, computational modeling, and more. Kris holds a PhD in civil engineering from the University of Texas and a master's degree from Worcester Polytechnic Institute, focusing on computational fluid dynamics. So without further ado, please take it away, Kris and Christine.
Thank you, Jessica. Let's take a look at what's the agenda for today's webinar. First, we're going to take a look at an overview of what Anaconda is, for those of you who are not familiar with the ecosystem. Next, we're going to take a deeper dive in what we mean with end-to-end collaborative data science workflows. Following that, we'll present what do we mean by the 3 ways you can develop and deploy data science artifacts. First, we're going to look at the Anaconda and Docker integration. Then we're going to follow up that with introducing what Anaconda Projects is. And finally, going into Anaconda Enterprise and the capabilities that exist in our product. I'll then pass that along to Kris Overholt, who's going to give you some examples of data science deployments and how to get started with Anaconda Enterprise. So let's take a look of an overview of Anaconda and what that is. So for those of you who are not familiar with Anaconda, Anaconda is the leading data science ecosystem with over 4 million users. So at the core of Anaconda, there's the Anaconda distribution, the most trusted distribution for data science. It has like the most used Python data science packages like NumPy, Pandas, Dask, Bokeh, TensorFlow, Scikit-learn, etc. On top of that, we at Continuum Analytics, we do offer an Anaconda Enterprise, which is a data science platform, and we'll see a little bit about the deployment capability of that platform in this webinar today. Anaconda is trusted by leading partners in the ecosystem like IBM, Microsoft, Cloudera, Hortonworks, Intel, NVIDIA, Docker, and Esri. For those of you who are enterprise customers, you might be interested also in Anaconda support for both the distribution and the enterprise, and also services and trainings that we offer for that. So as I mentioned earlier, at the core of the Anaconda ecosystem, there's the Anaconda distribution, which is a Python and R distribution with over 1,000 packages that are curated by Continuum Analytics that makes it really easy to get started with data science. There's packages for machine learning and statistics, for scientific computing, for distributed systems, for web development, and analytics and business intelligence. So Anaconda distribution is free to download. You can go to our website, continuum.io/downloads, and get Anaconda installed on your laptop. We have installed it for Mac, Windows, and Linux. So you can get started right now, today, very easily with all those curated data science packages. So what's inside Anaconda distribution once you install it? So Anaconda distribution is composed by several things. At the core of it, there's Conda, which is like the leading package and environment manager. On top of that, or through Conda, better said, there's these data science libraries where you get some of them through the installer, but you can get a lot more with the conda install command. So things like different interactive data science environments like Jupyter or Spider, analytics and scientific computing libraries like NumPy, SciPy, Pandas, Dask, Numba, visualizations to build your dashboards and charts like Bokeh, HoloViews, Datasheet, and Matplotlib, and also your machine learning and stats like TensorFlow, Scikit-learn, H2O, or Theano are all included in the Anaconda distribution. We also include a package that's called Anaconda Project, which allows you to easily make data science project encapsulations that are portable and allows you to build them locally and then deploy them in server-side tools like Anaconda Enterprise or any of the other methods that we're going to showcase in today's webinar. For those of you who are not very comfortable in the command line, Anaconda distribution comes with a graphical interface called Anaconda Navigator that allows you to perform all those activities such as updating packages and getting the latest ones, launching Jupyter or other interactive data science environments, all from a point and click interface instead of running from your terminal or command line if that's not something you're comfortable with. So let's go through all these different layers in the Anaconda distribution to get you familiar with, in case you're not already part of the ecosystem or this is new to you. So that, as I mentioned before, Conda is the leading package and environment manager. It allows you to do things such as install data science libraries. For example, a command we have right here is conda install pandas, which allows you to get the latest version of pandas, which is an analytics library in Python. It also allows you to manage different packages versions. You know, as versions get updated, your dependencies might target just a specific version of it. So in this case, Conda allows you to install that specific version you need for your data science project. As we install Anaconda and have Anaconda in our desktop or laptop, we might be working on different projects. These different projects might have different dependencies. Like one project might be using Python 2.7, another project might be using Python 3.5, or different libraries dependencies, like one version of Pandas 0.14 versus 0.18. So we want to create these isolated environments, and Conda allows you to create them and name them. For example, and this is something we have right here. We have a Conda create my environment with Python 3.5 version and a Pandas 0.18 version. Once you're in that environment, and maybe in some cases you might want to update your package to the latest versions, and you also get a command for that. So you see that it's very easy from the Conda command line client to be able to manage all the dependencies in different environments for the data science projects you have in your desktop or laptop. Let's take just a quick look of things that come with the Anaconda distribution or that you can also get through the Conda command line. So there's different data science environments like Jupyter Labs, things like Spider, that allow you to build your data science projects from a interactive development environment specifically targeted for data scientists. There's also a multitude of analytic and scientific computing libraries such as NumPy, SciPy, Numba, Pandas, or Dask for doing things like computations on your data to get some basic statistics, or doing like more advanced computations with array computing. We also have visualization libraries for like Bokeh, HoloViews, Datasheet, and Matplotlib, and machine learning libraries like TensorFlow, Scikit-learn, H2O, or Theano, and many more data science libraries that come with the Anaconda distribution or that are accessible to you through the Conda command line interface. A very important thing that comes with the Anaconda distribution is the Anaconda project library, which allows you to encapsulate your data science project in a portable way so that what you develop locally in your desktop can be deployed in either in your server-side component, if that is Anaconda Enterprise, or if it's any like server-side that you manage yourself, as we'll see further along this webinar, as a deployment option that you might have. So Anaconda project allows you to define and manage what are the project package dependencies, like what version of Python you're using, what version of the different libraries we've seen earlier is the project leveraging, like for example in this case, a specific version of Bokeh or a specific version of Pandas. It also allows you to define deployment commands of what's the artifact you want to deploy, and then what are the data dependencies that this project is using. In this case, for example, it's using some finance quantitative data from daily stocks from the SP 500. As I mentioned earlier, this is like our data science graphical interface called Anaconda Navigator that comes with the Anaconda distribution, which allows you to do things like launch applications, manage package versions and environments, or create and upload projects through a graphical interface without having to type commands from your terminal. For those of you who are not familiar or not comfortable in the command line. So let's take a look at what do we mean by end-to-end collaborative data science workflows. So I would distinguish it between kind of two stages. The one where like as a data scientist you're exploring, analyze, and collaborating with other data scientists to find different insights in your data, in your project. And then there's the phase where you are trying to scale, deploy, and operate those insights into your larger organization, or to your larger data if you start out with a smaller sample set. So for explore, analyze, and collaborate, you usually start with some data that exists somewhere, and usually like there's either data scientists or business analysts who are in this workflow process of cleaning, tidying that data, using some prediction, simulation, or optimizing data goal in your data science project that you want to perform. You then might turn into like some kind of visualizations to allow you to summarize those insights, and then query back your data for a subset of the existing source, and then kind of iterating over on that cleaning and tidying, predicting, simulating, optimizing, visualizing, and querying. And you might have some business analysts who are part of that workflow. They're usually more concerned like the querying, visualization, and reporting aspect of it. So I'm interested in seeing like what are the outcomes that this roles are responsible for. So we usually see that business analysts might be responsible for reporting some content or some summarization of that data, making some presentations for upper management on some like what are the insights, conclusions of those reports. And more we're seeing more of this kind of next generation predictive analytics or being performed by data scientists, which consists of interactive notebooks. So reports that get updated either daily or even like at that precise moment with the data latest values that exist in your data store. They are also responsible sometimes for building interactive data applications, which allows some of this managers or C-suite level employees, or maybe even like any other data-driven employee that needs to use some of data that exists in your organization to make some decisions. So these interactive data applications allow for these end users to get those insights that they need interactively without the data scientists having to specify exactly what visualization they need, and leaving out some widgets, some interactivity for that end user to kind of customize the insights they need to find. And finally, we also find data scientists feeding either web developers or other data scientists with some predictive models that they usually deploy as REST APIs, so that those consumers can kind of use advanced machine learning without having to develop those algorithms themselves. Another workflow that is not very data science interesting, or it's not very interesting for data scientists to perform, is the scale, deploy, and operate, which is traditionally done by DevOps, developer, and data engineers. But in smaller organizations, or in organizations where data scientists are kind of new to the team, end up being performed by this new role. And that includes things like, okay, where are the data scientists going to run their computations? Is it going to be on the cloud or on premises? How are they going to scale those computations? Are they just getting a sample to do that initial exploration, and then they have to scale it up to all the existing data? Where is that cluster live of data? Is it internal? Is it somewhere in the cloud? And then how do they deploy those insights that they found, like dashboards or notebooks or predictive APIs, to be shared with other people within their company and make that operationally efficient? So we see right now kind of this workflow that is constant, right? Once we have something deployed, you need to like keep operating it, redeploying things as they get newer versions, and making sure that you're using the right infrastructure, either cloud computing or on-premise, and then you're pointing to the right web services or internal clusters. This is a pretty heavy, kind of sophisticated workflow for data scientists who are usually more interested in this first analyze, collaborate, explore workflow that we've seen, but that sometimes in organizations they're kind of constrained to also be the owners of the scale, deploy, and operate. So we're going to take a look at how we can do data science development and deployment with Anaconda. And 3 ways we've discovered people are using Anaconda to deploy data science artifacts. So there are many challenges that data scientists face in these different workflows that were shared with you. The first one, once they've downloaded Anaconda distribution for our own website, they kind of ask us questions like, how do you download and install data science libraries? How do you manage different versions of those libraries and their dependencies? How do you upgrade libraries to the latest ones? How do you isolate those dependencies between different projects that you might have that have different dependencies requirements? As we mentioned before, maybe you have a project that depends on a group using Python 2.7 and another group in your organization that might be using Python 3.5. So before we ask those questions, let's take a look at we just gave a brief overview of some of the artifacts that data science were developing. Let's take a deeper loop. So we have this workflow we've defined earlier, where we have data scientists looking at data, doing some cleaning, tidying, predicting, simulating, optimizing, maybe doing some visualization and querying back some of the subset of the data that's available to them. From that, what's their output once once they've gone through that workflow? And we've observed at Continuum Analytics that they might develop different outputs or outcomes. So one of them might be just some process data, some data that you get data in and you do some processing on it and you get some output back. A lot of times their actual output is an interactive report leveraging Jupyter notebooks. They might be making that data accessible through interactive data visualizations and dashboards. They might be creating predictive models for other people in the organization to consume. They might just like be developing workflows, so processes that might be in a schedule, jobs like to generate some type of report or to update some data in their process. And then a lot of times it's just like plain scripts that they just like run on demand to get some updates on their visualizations or in their models, or in whatever data analysis they want to perform. So that's kind of a typical scenario where we see you're working on as a data scientist, you're working on your laptop, you download Anaconda, you get some Python or R with all these different packages like scikit-learn, Bokeh, TensorFlow, etc. Then in your local desktop, you maybe run some scripts, you have like some notebooks, some data set, and you have this like kind of custom environment you've created to solve the problem locally. And then you ask yourself, okay, now I have all these things that I've created, all these insights that I've gathered from my local analysis, and now what do I do? So there's like the challenges that come with data science development deployment, such as like, okay, now that I have this locally, how do I share the same insight with other people in my team? How do I share this data science project that I've developed and have it with make it accessible to others, and make sure that other people in my team can actually reproduce the same results I get from running this analysis. And a similar question people get ask themselves is, how do I then deploy this project so that other people can consume it and I'm not the only one kind of running the scripts or these notebooks in a desktop or local environment where no one else can find the insights that I'm getting. So let's look at a simple path defined with Anaconda and how to get to simple data science deployment. So of course the first step, the first easy step will be, do it yourself, figure it out yourself, and just use whatever process or system you have in your organization to move your scripts into a production environment. And that is fine, just go figure it out yourself. But for this webinar, we're kind of, the title of it is 3 ways you can use Anaconda for data science deployment, and kind of like they leverage each other up. So we can start with just like plain Anaconda distribution and how to leverage that with Docker containers and Conda environments. We'll then introduce in a little bit more depth what Anaconda project is, and finally we'll see how Anaconda Enterprise Continuum Analytics Enterprise product can help you very easily deploy your data science projects. So Anaconda and Docker better together. So the first way to deploy that's pretty simple is using Anaconda distribution with Docker containers. So we see here that we have a data science development environment where you have laptop, you download Anaconda, and then you can manage different Conda environments that contain their different environments. You can then use a Docker container with Anaconda on the server side to use as your data science deployment strategy, and just like use those same environments and so those same analysis and files to run it in a production environment. We do have noticed that kind of this strategy helps data scientists communicate with their DevOps teams in their organizations, and so kind of keeping everyone happy in this organization where data scientists can get to use Anaconda and DevOps teams get to use Docker, which is kind of their preferred tool. We do offer in Docker Hub Anaconda images where you can install from Docker pool continuum.io /Anaconda, and that will give you an image with the Anaconda distribution in it. So the Anaconda Docker strategy helps you manage your dependencies within like the different content environments, or whatever you use locally can be used in that container as well. But then it's kind of left to the audience, to the user, to decide how they're going to manage data, deployment commands, manage security, scalability, and availability of their data science project. So from here we evolve. At Continuum Analytics, we took a look at the Anaconda and Docker story, and we realized that data scientists really don't want to get into the depths of Docker containers, and they want a simpler data science abstraction. So that's when we developed Anaconda project to make sure that we create a portable data science artifact that is more than just Docker files and doesn't add the complexity that data scientists really don't care about. That DevOps, might be pretty interested in with using Docker, and that just like hide all that complexity for data scientists in the Anaconda project abstraction layer. So what Anaconda project allows you to do is mimic your laptop data science environment to the server-side component where you do deployment. So you run in Anaconda project locally the same way you're gonna deploy that project on your server side. With Anaconda project, you can also add a Docker container if that's kind of the preferred deployment mechanism in your organization by your DevOps team. And that allows it allows data scientists to add not only dependencies that we saw before can be done with Conda environments, but now you can also add project dependencies such as data, or how you actually want the project to be deployed via the deployment commands. Still, it's kind of left to the reader to define what are the security, scalability, and availability requirements and definitions. So in that case, that kind of project doesn't offer any additional capability. It's up to the user or the person in your DevOps team to define that either in the Docker container or their deployment method. Finally, we want to present the one-click data science deployments with Anaconda Enterprise. So we're kind of like walking this three-way mechanism that gets easier as you go with it. Easier, or we end up managing more of those capabilities and requirements for you. But you can always use the Docker and Anaconda method or the Anaconda project method, and just like figure it out yourself. How do you want to deploy that artifact yourself? But if you're a part of the team that just like wants very like enterprise ready, very simple one-click data science deployment, this third method might be the one that is more compelling to you. So in Anaconda Enterprise, what we do is like we hide away all the complexity around managing Docker containers and things like Kubernetes from the end user, and basically it makes it very easy for data scientists to run whatever project they've developed locally and just like deploy it inside Anaconda Enterprise. So it's just like uploading a project and click it, deploy on it to get that deployment capability. Anaconda Enterprise also offers you to do all the development on the server side if you wish to do so, or your company enforces that on the data science teams. By using Anaconda Enterprise, now you've gathered not only like the dependencies that the data and the deployment commands that are part of your Anaconda project specification, but allowing the product to handle security and scalability and availability for you without having to worry about it. So now I'm gonna pass the microphone to Kris Overholt, who's gonna give us some examples on Anaconda Enterprise, as well as showing how you can deploy different types of data science projects with Anaconda Enterprise. Here you go, Kris. Thank you.
Hello, everyone, and thanks for the introduction, Christine. That was a really fantastic overview of how to deploy data science projects and applications with Anaconda, Docker, Anaconda Project, and Anaconda Enterprise. My name is Christopher Overholt, and I'm a product manager for Anaconda Enterprise, and I'll be walking you through the detailed features and examples of how you can deploy data science projects, including self-service notebooks, machine learning models with APIs, and interactive applications and dashboards. Before we do that, I'd like to take a moment to show you some of the key concepts in Anaconda Enterprise and walk you through an end-to-end data science workflow with Anaconda. So to do that, I'm going to switch over to Anaconda Enterprise, and through here, this is our portal to Anaconda Enterprise Data Science Collaborative Workflows. So I'm going to log into the portal, and the first thing we'll notice is a welcome screen. And on this home screen, we see a few key concepts, and I want to focus on two of those concepts. The first one is a project. So a project is an encapsulation of your data science assets. It includes all the configuration and user code, including packages, environment variables, commands, and file downloads necessary to reproduce your data science environment. The second concept is an app. An application is a deployment of a project. So you can actually have one project with many different deployments, and each one of these applications is a reproducible and isolated data science environment, whether this is powering a notebook, live visualization, or a machine learning model. So if I click on projects, you can see a number of different data science projects that I have defined. Some of them are visualization, some of them are notebooks, some of them are models with REST APIs, and we'll walk through a number of different examples later in the webinar. Next, I'll show applications. So applications are deployed versions of projects. This means that I can take any project you see here, whether it's a notebook or a Shiny app or a Bokeh app, I can take that and deploy that with a single click on an Anaconda Enterprise server. So I'm going to deploy one of these projects just to show you an example. So the first example project here is a REST API server that serves out quotations. So what I'm going to do is click on Quote API, go down, choose the revision that I want, and choose the command that I want to deploy. When I do that, it's a one-click deployment to the Anaconda Enterprise server. What this is doing is reproducing my data science environment necessary to run this code. So this includes any dependencies in Anaconda that are Conda packages. This also includes the user code that I have to run this API server. And after a few moments, you'll see the app is up and running right inside of the Anaconda Enterprise platform. This is a JSON API server. I can make a request and get back a quote. So basically, with one click, I have a secure and scalable deployment of my API server. I can also look at application logs. So this is very helpful when I'm developing an application as a data scientist. I can look through the logs and see how my service is starting up, how my API server is working. I can also see if I'm missing any dependencies. So basically, we made it very easy with one click to go from the desktop to a secure server and deploy projects and applications to anyone on my data science team. Once I've deployed this application, I can actually share this application very easily with other users on the data science team. And you can actually see here the Conda command that it's using to reproduce the exact environment that I created the project with on my desktop or on the enterprise server. There's also application health monitoring, status monitoring, and automatic restarts. So I can be sure that when I deploy something, it's always going to be up and running and able to be consumed by any users I've shared it with. I can also pop out and see that this application is isolated. I can pop it out to a new tab, and I'm using end-to-end encryption and security. I can also share with other users on my organization, so I can share with Christine, and with one click, Christine now has access to my deployed application and can consume its APIs. You can also consume via tokens, and we'll talk about that in a later example. So now that we've defined those key concepts, I want to give an overview of the functionality that we're going to look at in the deployment feature of Anaconda Enterprise. So earlier in the webinar, Christine described Anaconda Enterprise as a platform for end-to-end data science workflows, and I want to focus on data science deployment before we get to the detailed examples. So in data science deployment, Anaconda Enterprise gives you one-click deployment of self-service data science notebooks, including Python notebooks and R notebooks, interactive visualizations and dashboards, including bokeh, shiny, and we'll show a number of those in a moment. One-click deployment of machine learning models with REST APIs. All of these are being deployed securely to a cluster with end-to-end SSL. You don't have to configure this for every deployment. It's just automatic as part of that one-click deployment process. We also provide an API wrapper for easily exposing inputs and outputs for models, and we give you the ability to securely share apps within your enterprise organization, users, groups, roles from LDAP, Active Directory, SAML, and Kerberos. Other features of the deployment functionality of Anaconda Enterprise include the ability to deploy applications and APIs that can be used or consumed by other members of your data science team via a secure token. Also the ability to configure CPU and memory limits for deployed apps in a system-wide configuration. So we can specify how much CPU and memory each application should use across the Anaconda Enterprise cluster. We also have the ability to fetch logs for each app like I showed earlier, with error handling, health checks, and automatic app restarts. Also, your deployments are not limited to Anaconda. They can be backed by any remote storage, databases, or Hadoop Spark clusters that you might have. So you can power visualizations and dashboards with remote data and remote compute resources. Finally, the cluster can be configured for high availability. So what this means is your users don't have to worry about whether their deployed application will be up and running. We take care of that for you. If a cluster node goes down or becomes unavailable, it will automatically be restarted on another cluster node for you. So now I'd like to show some example data science deployments. And we're going to walk through a number of different categories. So an overview of those categories are self-service notebooks, including Python and R, interactive visualizations and dashboards of various visualization toolkits and frameworks. I'm also going to show an example of a machine learning model with a REST API and how we can query predictions from a trained model. I'm going to show composable data science projects, which means different members of your team can deploy applications that build on top of other applications. And finally, I'll show machine learning model with visualization toolkit. So the first example I'm going to show is dealing with notebooks. So here we can deploy self-service data science notebooks, including Python and R. These notebooks have live attached Python processes and notebook kernels running with them. So your end users can actually rerun the analyses on the server side on a deployed notebook. You can also share runnable versions of your analyses. This means that if you have any queries for data of recent data, your applications can query that, your end users can do that without needing access to the credentials that you've built into your project. You can also share your running notebooks with users, groups, and roles, so they're not just looking at a static version of a notebook, they're actually looking at a live notebook. So we're going to show that and how we handle portability and manage dependencies with Anaconda project. So in this simple case, I'm going to look at a notebook called stocks live, and inside of this directory I have two files. One is the IPython notebook or Jupyter notebook file, and the other is the Anaconda project descriptor. We'll look at this in a moment, but this basically describes what Conda dependencies and which Anaconda packages I need to run this analysis. So if I run this Anaconda project, it's going to open in my browser, and I'm going to see the stocks live notebook. So this is running locally right now, and it's actually reproduced the environment that I need, including the packages and dependencies, things like bokeh, numpy, pandas, and this is grabbing the latest financial data from Yahoo Finance, and it is going to do some data cleansing and is going to generate a bokeh plot of the recent stock ticker data. So we're looking at recent data. Basically, at this point, we want to be able to deploy this notebook in a way that other members of our data science team can consume and even run on their own, so they're always looking at the latest data snapshot available to them. So I'm going to show you how to do that with Anaconda Enterprise for one-click deployments of self-service notebooks. To do that, I'm going to show the Anaconda Navigator interface, which now has support for Anaconda projects. You can see I've added a stocks live notebook project to Anaconda Navigator. And on the right side, you see a couple of files. You see the notebook file, and you also see an Anaconda project that I referred to earlier. We'll look at that in a moment. Basically, this project has everything I need, including the user code and the list of dependencies that I need to run this on Anaconda Enterprise server. So inside of the Anaconda project definition, we have the project name, we have the name of the notebook, and the important part is the list of packages or dependencies that this notebook needs in order to reproduce its data science environment. You'll notice it has Python 3, it has a specific version of Bokeh and Tornado, Jupyter Notebook, and Pandas. So with this information, we have everything we need to have a portable Anaconda project without having to edit Docker files by hand or any other messy details. Everything here is self-contained. We can then upload this to Anaconda Enterprise with one click. From Anaconda Enterprise, we can deploy this notebook. We can select the revision command and click deploy. Once we've done that, we have a one-click deployment of a secure and scalable self-service notebook that exists in Anaconda Enterprise. I can share with my team. So in a few moments, we'll see the notebook spin up, and we'll see the same version of the notebook we were running locally running in Anaconda Enterprise. So now, on the right side of Anaconda Enterprise, I can see the same exact notebook. It's reproduced that environment, it's isolated that environment, and given us an endpoint just for this self-service notebook. So I can rerun the analyses on the server side, and I can see it running the cells live, and I see the same plots that I saw in the local version. I can also pop this open in a new tab, and I can rerun everything here. It's all running securely on the Anaconda Enterprise server. So I can rerun the analyses, and again, I have the latest data. So whoever I share this self-service notebook with, they can do the same thing, rerun the notebook. Everyone always has the latest data, the latest visualizations, they're all interactive. I can then share this self-service notebook with other users in my organization. So I can share with users or groups, and when I hit apply, it's shared, and when they log into Anaconda Enterprise, they're looking at the latest and greatest Stocks Live notebook or self-service notebook. Once I'm done, I can terminate the notebook here, and then that instance of the notebook will go away. The project is still around. I can redeploy it in different versions, or I can deploy many different times and share to different people if I'd like. So that's the basics of a Python notebook in Anaconda Enterprise. Anaconda is not limited to Python. We also support R. So I can deploy a notebook. Here I have an R predictive notebook, a predictive model with linear regression and ggplot. So first we load the libraries, we load data, we select and fit a model, make some predictions. We can see the results there. And then finally we can present the results with ggplot. So here I'm running with a live R kernel and a live R process. I can also pop this open to a new tab and see the deployed self-service notebook in its full form. And people I've shared the notebook with can also rerun the analysis and see the same visualization results. They don't have to worry about dependencies, portability, uptime. We handle that all for you in Anaconda Enterprise. Another notebook is a Markowitz notebook looking at portfolio design using Pandas and Bokeh. Again, each one of these projects has all the dependencies specified, so it's reproducible across different operating systems and on the Anaconda Enterprise server. So I'm going to rerun this analysis, and we're going to look at some analysis with different stock ticker data and portfolio design. And basically we're doing various things with NumPy, with Pandas, and generating Bokeh charts that are interactive. The interactivity is preserved when I share that, and of course users can rerun the analysis on their own once I've shared it with them. So here you can see we popped open to a new tab. We're looking at the Markowitz notebook. Again, this is isolated, running in its own environment, and shared only with the users on my data science team that I want to share it with. And so here I see that I'm interacting with Bokeh charts. I can do typical things I would do in Bokeh, and the interactivity is preserved. If this were making any remote queries or backed by a Hadoop or Spark cluster, that's possible to do with an app deployment as well. And so here we see some of the return data and one of the final plots of this analysis in Bokeh. And here is a scatter plot. Again, anyone I've shared this with can rerun the analysis, and we'll close that out. So that covers the use cases of self-service notebooks. We showed Anaconda Navigator. We showed how to deploy Python in our notebooks. And next, I'd like to show some examples of interactive visualizations, applications, and dashboards. With Anaconda Enterprise, you can deploy apps using any visualization package in Anaconda. Some of the popular ones are Bokeh, Shiny Apps, Data Shader for large data sets, and a newer visualization library from Uber called deck.gl. This makes it very easy to develop and share visualizations and dashboards. You can also reference external data or have these visualizations backed by Hadoop or Spark. So I'd like to show a few of those examples now. First, we'll look at a data clustering example, and we'll open this up in a new tab and see that it's running in its own environment. We've deployed this project as an application, and what this means is I've developed a bokeh application that's doing clustering on some data, and here I can share this with other users, and they can actually do some of the exploratory analysis themselves, and this is all running with scikit-learn in the backend. Another application is a stocks application, which is a bokeh interactive app, and I've deployed that as an application, and I can see as I'm selecting data, the bokeh plots are updating in real time because they have a live bokeh server and a live Python process associated with it. And anyone I share it with can do the same thing and analyze this data. You see some of the linked plots. When I select data in one of the symbols, it reflects in the scatter plot and in the corresponding ticker symbol. And I can also do linked zooming, linked box selections, things like that. I can also use other visualization frameworks. So in this example application, we've deployed a surface 3D plot using the viz.js library. So right inside of the browser in Anaconda Enterprise, I can interact directly with the viz.js visualization. I can rotate, zoom, and anyone I share it with has this already up and running in Anaconda Enterprise. No need to install or worry about dependencies or Docker files. We handle that all for you with Anaconda Project and Anaconda Enterprise. And finally, here's a streaming data example. So this is some mock data coming from that we're generating and visualizing as if it were financial data, and we can tweak various parameters in the bokeh application. I'd like to show some other visualization frameworks that you can run in Anaconda Project. So deck.gl is a WebGL accelerated visualization library that can be used to do 3D visualizations of data, especially geodata. So here we have GeoJSON data. And notice that I've run one command, Anaconda Project run, and what this is doing is it's reproducing the data science environment, assets, and dependencies that I need for this project. I don't have to pre-install anything. It's just using the power of Anaconda to reproduce this environment, and then I can open up in my browser and see the deck.gl service running. And in this case, it's GeoJSON data, and it's visualizing some data from Vancouver. And we can scroll around and pan around and zoom in and out, and it's again, this would be a one-click deployment with Anaconda Enterprise. No need to install any libraries or anything. This is all being done via the browser, and we could deploy this as an app and securely share it with others who could explore this data. Another popular visualization framework is Shiny. Shiny is a web application framework for R, and Anaconda makes it easy to create and deploy Shiny apps with Anaconda Enterprise. So I can start up my Shiny app, and I see on the left, as I adjust the number of observations, the histogram on the right updates in real time because it has a live R process and Shiny server running. So we make it very easy to do one-click deployments, including R and Shiny applications with Anaconda Enterprise. Also, I'll show Data Shader. Data Shader is a project, open source project supported by Continuum that makes it very easy, is very powerful for visualizing very large data sets. So this is the New York City taxi data set, and we're actually looking at New York City taxi drop-offs, and the variable we're looking at is trip count. And Data Shader lets us see very dense data sets with millions of points. We can change things like the color map, we can change spread size, hover. Everything you see here is being calculated and rendered in real time. There's no pre-rendered layers here. So as I change the selections on the left side, everything on the right is being computed. And again, it's a one-click deployment to make that available on Anaconda Enterprise. So those are some examples of interactive visualization frameworks. The next set of examples I'd like to show deals with machine learning models with APIs. So with Anaconda Enterprise, we make it very easy to develop applications with machine learning models, especially with REST APIs, using packages in Anaconda like scikit-learn, Theano, Lasagna, Neon, and including TensorFlow with GPU support. Caffe and many of the machine learning libraries in H2O can all be installed with Anaconda and deployed with one click with Anaconda Enterprise. There's many other machine learning libraries that we're not covering here available in Anaconda. We also have support for model scoring and prediction APIs from trained models, and we're compatible with web frameworks in Anaconda, including Flask, Django, Tornado, and others. Finally, the models can be shared or consumed via API tokens, and we're going to show an example of that right here with a trained machine learning model. So I have a project called House Price Predictions, and in this project it has everything I need including the data, the training data, test data, a pickled version of the model, and some Python scripts that generated the trained data and also query the data. And in here we describe our dependencies with Anaconda project, and we've essentially pre-trained this model and stored the model as a pickle file that we'll be able to use as part of our deployed application. So in the project file we have a name, description, and here you can see the command that's running is python main.py, and the important thing is the packages. So here this project depends on Python, Pandas, Tornado, and XGBoost, which is an extreme gradient boosting library, and we're going to do a regression on house price data. So I'll show some of that now, and if I go inside of the folder that contains the Anaconda project, I can see that I have a few Python scripts. So here I have a classifier, and I'm serving that out with Tornado. There are my routes, so I have a couple of routes for API access. I also have a script to classify the data. And then I've trained the data inside of this notebook, and I'll show that in a moment. So if we go into this project folder, this is house pricing data, and it includes about 80 different features on the data, things like the floor area of a house, the number of floors, and different features of a house, including the training data includes the sale price, and we basically want to be able to submit test data that has these variables like the year the house was built, square footage, if there was remodeling, and we want to get back predictions of the home price based on these submitted features. So here's what some of the data looks like, and then here's where we train the data, and then we are using XGBoost here to do a grid search across there, and we're essentially doing a regression across all of this house pricing data. And here we're using XGBoost to train, and we've pre-trained this, and then the important thing is we're saving the resulting model as a pickle file, and we're going to use that in our deployed application. So if we go back into the project directory, what I'm going to do is I'm first going to run this trained machine learning model with the REST API locally, and we're going to hit that REST API locally in our browser and see what that looks like. So there's a couple of options when we hit this API. We can hit it with an API with a Python script. We can also hit it directly with curl, and we're going to do that first locally so we understand what's going on, and then we're going to do that remotely running on Anaconda Enterprise with one-click deployment. So first we use curl, and we're hitting the local API endpoint, and you can see it's returning scores from the model. And essentially if we take the exponential of each one of these numbers, the REST API is going to return the predicted sale price of the home. So here what we see, the exponential of 12 is about $165,000, and we're seeing predictions coming back based on our test data. So now I'm going to show you how you can deploy this machine learning model with REST API with a single click, and that's all it takes right there. So right now this machine learning model in its entirety is being launched on Anaconda Enterprise, and we're going to be using the pre-trained model that we just trained in the notebook. And that's it. The model is up and live and running. We can generate a token so that others can access this model programmatically via curl or via a Python script or any other API consumption method. So we see the API has a unique URL or endpoint, and it has a token that we just generated for this API. So what we can do now is we can first use curl to hit this deployed API. So there's two things we're going to provide. We're going to provide the token, and we're going to provide the unique endpoint to this machine learning model API. So we grab the port number from our deployed version of the app, 32615, and then we insert the token that we generated for this REST API. So I'm pasting in the token, and now when we make our curl post request, we're getting back those predicted the predicted scores for the home pricing. We can also hit the Anaconda Enterprise REST API via a Python script. So it's very easy to put in those same two things, the port number, the unique endpoint, and the token. and this token will allow us to send over test data in a post request and receive back the scores from the model. So after a few seconds, we will see the results coming from the model. So this is very interesting because this is where leading into our next section where we talk about composable projects and deployments. So in that case, we're using curl and we're using Python scripts to manually consume information from a trained machine learning model. But another thing you can do is to compose deployments. So maybe you want to compose applications across your data science team for different members of your team. So an example end-to-end workflow with custom endpoints and API tokens could be, first we want to cleanse the data, then we want to do anomaly detection, then we want to do model scoring, and based on those results, we want to develop interactive applications, dashboards, reports, and file exports that other members of the team can use to consume the results of my data science analysis. So we're going to show an example of an image classifier, and we've broken it into two parts. So this is an image classifier powered by TensorFlow and Anaconda, and here you see the dependencies for the API. So we have two separate projects. One is the classification with TensorFlow. This is trained data on ImageNet data using the Inception model. And so here we have a couple of hundred lines of Python code, and this is essentially our classifier, and it's going to serve out on an API. And then the second part of this application is a interface in Flask. And the nice thing here is we can use the REST API URL and the token, and we can actually compose deployments on top of each other. So if one member of the data science team works on a classifier, deploys it, and shares that, another person can develop the front end for that and can use the token to securely consume the results of those image classifiers. So in this case, we're going to use the user interface to submit an image and to return the results of image classification. So if we go into the project directory, we're going to go into the UI project, and essentially I've already deployed the image classifier API. I've generated a token. I've put that token into my UI project, and now I'm going to deploy the UI portion of this project. So if I deploy that, it's going to build on top of the API. It's actually going to be talking to the other deployed application. So I have a two-part application with one interface that's serving out to my users. So this is very nice. I could continue to build on top of that to build additional visualization tools or dashboards or exporting tools. So in a few moments, the UI service is going to be up and running. And if I go to the UI service, I can now upload an image. So at this point, I'm going to select an image and upload it to the UI. So this is now talking to the API service, and when I hit classify, it's using that API to classify my image, returning that results to the UI application. And here we see the results. It's 93% probability. That's a giant panda. That looks correct to me. This is a very nice example of how you can compose projects and you can continue to build on top of projects as an iterative workflow in your data science team. So those are the two deployed applications talking to each other securely. I can then share the UI application with other users. So here I shared with Christine. She can access the UI, and it's doing all the API communication, security, and tokenization behind the scenes. The final example I want to show is a machine learning model with visualization. So data science projects with visualization can be built on top of machine learning libraries in Anaconda, including TensorFlow, H2O, and many of the other libraries I mentioned before. This makes it very easy to develop interactive applications and dashboards with existing frameworks and deploy them with one click to Anaconda Enterprise. It's a nice way to handle inputs and outputs to machine learning models, especially during the development process. This includes complex visualization toolkits like TensorBoard, which is included with TensorFlow and Anaconda. So I'm going to show an example of TensorBoard running as an Anaconda project and deploying that to Anaconda Enterprise. So here the dependencies are very simple. It's Python and TensorFlow. We take care of all the C dependencies and Python dependencies for you once you've listed those two things in your project. And here we see we're going to take the MNIST dataset. This is a dataset of handwritten digits, and we have a TensorFlow model built with convolution layers, and we're going to use this to classify the handwritten digits in the MNIST dataset. So this is a trained model, and we're going to be looking at the results in TensorBoard visually. So with one click, just like everything else in Anaconda Enterprise, we now have a secure and scalable deployment of our TensorBoard application. So after a few moments, it's recreated the data science environment and all the dependencies I need to run TensorBoard. So I can open this up at its unique endpoint in Anaconda Enterprise, and after a few moments it loads the data, and in the TensorBoard interface I can essentially look at all the different runs across my model. I can look along the top navigation bar. First we're looking at the scalars. So here we're looking at the accuracy of the different models. We see the dark green at the moment has near 80% accuracy, and then we can see the error over the iterations along the bottom. The embeddings is going to grab all the tensor values, and it's going to do principal component analysis and show us the actual results of the model and the handwritten digits classified. So here we're looking at all the digits from 0 to 9, and if we apply a color map, we'll see how these were classified between 0 and 9 based on the TensorFlow model. And what we're looking at is a spherical 3D representation of those handwritten digits, and I can do things like select all of the items that with the label 7. I can zoom in and out and see a visual representation of how these handwritten digits were classified. And from here, there's a few other things I can look at. I can also select some of the values and see those grouped on the right and what values matched. It's a very nice way to visually explore the results of my neural network. And I can also look at histograms and distributions. So here I'm looking at the biases, activations, and weights of the different convolution layers. I can look at histograms, which show those values over the different iterations, or I can look at distributions of all of those hyperparameters, the biases, the weights, and so on. I can also look at the graph itself, and of the different model runs, I can see basically the workflow that's going through, the number of tensors, number of convolution layers, and so on. And if I look at the images tab, I can actually look at a sample of the raw data and see some of the images that were classified, the handwritten digits. So TensorBoard is a really powerful visualization toolkit, not only for the end of an analysis, but actually while you're developing a neural network. It's a way to get great feedback about how your model is developing, how the performance of different models compares to one another. So with that, that's the last category that I wanted to show of example deployments. And now that you've seen these different applications and deployments, I wanted to show you how you can get started with data science deployment with Anaconda Enterprise and the Anaconda platform. So the Anaconda platform is composed of three primary components. It's the Anaconda distribution, which is the most trusted Python distribution for data science and the easiest way to get started with machine learning, visualization, and data science overall. There's Anaconda support, which helps you deploy Anaconda with confidence. And we offer world-class support for open source production environments. And finally, there's Anaconda Enterprise, which gives you enterprise-ready data science platform for end-to-end workflows, including governance, collaboration, and data science deployment. In addition to one-click secure and scalable data science project deployment, Anaconda Enterprise empowers your data science team with a number of other features for end-to-end collaborative workflows, including world-class support for open source production environments, the ability to securely govern and version control data science artifacts, including projects, packages, and installers, from development all the way to production. It also offers secure and scalable data science project collaboration within your organization. It helps you manage Anaconda across a cluster and run data science calculations backed by scalable compute and data sources. And finally, it brings the power of data science to business analysts via Microsoft Excel. The best way to get started is via the Anaconda Enterprise Innovator Program, which you can access the link here. That'll get you access to perform data science deployment like you saw today. You can also get in touch with us for more information about Anaconda Enterprise and then how we can help empower your organization to do better data science deployment, reproducible data science, and governance across your data science team. And with that, I'd like to thank everyone for their time and attention today. in learning about data science deployments for secure, scalable, end-to-end workflows on your data science team. We look forward to working with you to empower your data science team for collaboration, governance, deployment, and scalability. And at this time, we'll take any questions you might have. Thank you.